Good morning. In this lecture series, we see about the problem on stress. As we know that how they form the local and coordinate system, and is a formation of the global coordinate system, and we have to study the stiffness matrix for the corresponding stress. So now we are discussing the problem on the stress. So first of all, what is the basic concept of the problem stress? So as we know that the introduction in the stress in the FEA, the stress is a structural assembly and composed for the slender bars and connecting the frictionless pin joints and their ends. These members carry only the axial force, either the tension or compression, with no bending moment. The finite element analysis they extends the classical static principles, enabling the engineers to solve the statistical determinate stress with the easy. So FEA handles the complex 2D and 3D stress configuration that would be the impractical or the impossible to solve the traditional handling calculation alone. So these are the general the outcome of the global stiffness matrix. So the first of all, in your problem, you have to find out the number, and each member they have a two nodes. Okay, so whether it's like a triangle, if you consider the stress look like a triangle shape means okay. So we have here the three members are there, so that the correspondingly the joints or the nodes also we have to classify into six. Okay, that means the members into two. Okay, so totally here the total number of nodes here is six. Okay, so and then the each member you have to calculate the stiffness matrix based upon your node position. So like for example, the member one means the node number one and two. The member 2 means 2 and 3 and 3 and 4. Likewise, we have to classify the node numbers. Okay. So here the overall constructions on the assembly of the global stiffness matrix. Once you have to find out the each local members local stiffness matrix, then we have to going for the global stiffness matrix. So that is the combination matrix. Assembly the element matrix into global. And also after that, once you have to assembly that based upon your problem, okay, based upon your situations, okay, we have to apply the boundary conditions. So the boundary conditions is based upon only the enforce the constraints and the modify the rows. So that means the eliminator or we have to add it. Okay, somewhat we have to modify in the corresponding rows or not a column, corresponding rows. And to solve the systems, how they called us the compute in the unknown degree of freedom as per the response. Okay. So once you have to calculate the find out the unknown displacement of the respective nodes. Okay. Then we have to find out the displacement and the corresponding force also. So then the solving the post processing. The once we have to solve the displacement of the respective numbers and node numbers, okay, we have to obtain the U that is called as a displacement vectors by solving the global system equations. So and then second one is calculate the element forces. So compute the axial force in the each element using the transformed displacements. Analyze result, identify the tension and the compression states, and check for the potential bulking risk. And validate the solutions. Compare the manual FEA result with the commercial solvers like ANSYS and Abacus for the verifications. So the axial force is the each element is called as used to N equal to K Q dash Q2 dash minus Q1 dash. So where here the Q1 dash and the Q2 dash are the local displacement at the element ends. So the example problem setup, the given information like a material property, geometry, load conditioning, and the support conditioning. So the material properties are the Young's modulus, cross-section area, and the node coordinates in 2D and 3D space, and the external force moment, and the fixed pin or roller support. So the objective of this problem is to determine the nodal displacement at the element axial force and supporting the reactions and the complete stress structure. So overall summarize of this stress analysis, the objective and the analytical method, a numerical approach, analysis process, engineering significance, and member force types. So the objectives are the internal member force, supporting reactions, nodal displacement. The numerical approaches, stiffness method, and the finite element analysis. Analyze process, idealization and assumptions, determining and stability checking, equilibrium and equations and boundary conditions. And the members force types are tensile force and compressive force. Thank you.